I'm sure everybody noticed there was that the continental bells rang in a completely random way, whereas our English bells rang in a rather musical and very rhythmic way. And that is one of the principal differences between continental bells and English and Welsh bells. So this is a set of English bells ringing, as I'm sure you've heard them ring. They were ringing in sequence, ringing down a major scale, and we call that ringing in rounds. And I think we tend to associate that sound with weddings and joyful things like that. So that was 8 bells ringing in rounds in a very rhythmic sequence. But it does get a little bit tedious just listening to the bells ringing down the scale. And so, going back over 300 years, the plucky English bell ringer has always thought rather further than just ringing the bells. So in Tintinnalogia, published in 1671, that was actually a compilation of all of the possible combinations of ringing any number of bells. So, quoting out of the book, on 4 bells there are 24 several changes. So these are all the possible sequences of ringing 4 bells. And what we can see in these sequences is that we start off with the bells ringing in order, down the scale, 1, 2, 3, 4, and then we swap over 1 pair of bells in the sequence. So we go from 1, 2, 3, 4 to 2, 1, 3, 4. And going through the bells, this is done in a very, very orderly and efficient way, a bit like going through your shopping list in a way. And we can see that we've done all of these rather pedantic swaps, and we finally got back to what we call rounds. So we've started in rounds, we've finished in rounds, and we've gone through all the sequences just by swapping over 2 bells that are next to each other in the sequence. So that is a little bit sort of pedestrian and unmusical to listen to, but that's the best you can do if you only swap over 1 pair of bells in each row. So now we have a great paradigm shift in bell ringing, because they said, well, why not swap over more than 1 pair of bells at a time? I sort of liken this perhaps to rock climbing, where normally you would just move 1 limb at a time. You never think of moving all your limbs at a time when you're on a rock face. And just swapping over 1 pair of bells gives you a sort of stability. But no, why don't we plucky English people try swapping over 2 bells at a time? 2 pairs of bells. So what we've got here is swapping So what I've represented here is 2x's meaning that 2 pairs of bells swap. 1x4 means the bell in the first position, the bell in the 4th position stays put, and the other pair swaps. So that's got a little bit more life about it because there's a lot more change between the rows. But what you can see there in what we call plain hunt is that after you've done 8 what we call changes, after 8 rows, you're back to the beginning again. So we haven't got our 24 several changes. So something else needs to happen. And this is a way in which we can get all 24 changes on 4 bells. So we've started off doing our plain hunt. So now we have our 24 several changes. What we've done here is that when we were about to get back to the beginning again, instead of just leaving the first bell and the fourth bell in place, we've now said we'll leave the first bell and the second bell in place and swap this last pair. And by doing that, we've managed to develop all 24 changes in quite a musical way. And that is called a method. And it's essentially, it is an algorithm for how we're going to ring the bells. And we've got all 24 possible combinations of 4 bells. And that is called plain bob minimus. Minimus means that it's rung on 4 bells. But we can extend that algorithm to any number of bells. So let's just have a look here. I'll be looking at extending the algorithm to any number of bells. But now I want to tell you a bit more about ways of thinking about this algorithm. So I've got the numbers written out here, and I've got X meaning all of the bells swap with their neighbours. 1, 4 means the first bell and the last bell stay put, and the middle 2 swap. Everyone swaps, 1 and 4 stay put, and the other pair swap. So we can summarise that algorithm by saying X14, 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 X12. Or we could say, well, we do X and then 1 and n stay in the same place to the power n minus 1. And then we do X12 stay in the same place, and we do the whole thing to the power of n minus 1. So we've extended that to any number of even bells. So that's fine if you're a mathematician looking at an equation and writing it all down, but what about the poor souls pulling on the ropes, ringing the bells? How do they remember that? Well, what happened? This rather clever Yorkshireman, 19th century Yorkshireman, Jasper Snowdon, wrote bell ringing books, and he recognised that a good way of teaching this was to draw a line through the path that the bells follow. So here we have a red line which shows the path of the bell number 1 or the treble. Here we have the blue line for one of the other bells, and you can see that follows a rather more complicated pattern, that the person ringing the bell learns the pattern, the blue line. Now, we can do an equivalent of a blue line through one of the other bells. And I've now put in a blue line through, well, it's a green line for the third bell. And we can see the pattern that the third bell adopts. And the very observant ones of you will have spotted that the line, the green line, is exactly the same as the blue line, but it's been displaced. So it's all cyclical. So every bell, apart from bell number 1 with the red line, does the same path, but joins that path at a different point. So Jasper Snowdon put in the blue line, and he's shown on that blue line where each bell starts. So bell number 3 starts on this part of the blue line, which is obviously what the green line is here. So when you're bell ringing, learning how to ring a method, you learn the blue line so that you have in your mind this pathway. Now I'm in first place, now I'm in second, now I'm in third, now I'm in fourth, now I go back to third, back to fourth, another in fourth, 3, 2, 1, 1, and so on. So we have that in mind. Now, that was great for playing Bob Minimus because it gave us every possible combination on 4 bells. If you extend this to 5 bells, this is plain bob doubles on 5 bells, exactly the same method, extend it to 5 bells, but it only gives us 40 rows before we get back to the start. But of course on 5 bells there are 120 possible changes, which is called an extend. So we need a cunning trick. And the cunning trick is that instead of just ringing all the way through this as it's written and then repeating ourselves, At some point where the treble is in the lead, there's a cunning trick which will swap over these next three bells. And by doing that at the appropriate points, what we do effectively is ring all of this, but with the bells in a different permutation at the start of the sequence. And so by very cleverly knowing when to tell the bells to swap over, we can get what is called an extent of 120 changes. So do that quite easily, get our extent on 5 bells. There are some much more complicated methods, and we'll just have a little listen to this. This is Cambridge Surprise Major. On 8 bells, it goes on for 160 changes before you get back to the beginning. What you'll see here is that the treble bell, instead of just doing a simple zigzag back and forward, it goes 1 step up, 1 back, 1, 2 forward, 1 back, which is what we call treble bobbing. So we have a zigzag path for the treble bell. And the other bells, oh my goodness, it's much more complicated. So I'm not going to go into this now, but the plain course is much more complicated. So that is Cambridge Surprise Major. You've probably heard of appeal. So what is appeal? Originally, it was the maximum number of changes on n bells, and it has to start in rounds and finish in rounds. So on 4 bells, it's 24 changes. On 5 bells, 120. 6 bells, 720. 7 bells, it's 5,040 changes, and this was first achieved in 1715. 5,040 changes, that is every single possible combination of 7 bells without any repetition. So the standard definition of appeal now is on 7 bells exactly 5,040. On any other number of bells, it has to be at least 5,000 changes with the minimum possible repetition. It takes about 3 hours. First done in 1715. 300 years later, I have to say this is my proudest achievement of 2015, because there I am. That was my first ever peal, rung in 3 hours and 1 minute. The name's different because I ring under my married name. So, a few practicalities. This is the sort of ringing motion. Most towers have either 6 or 8 bells. A lot of the cathedrals have 12. The bells usually weigh anything between about 100 weight, so about my weight, and a ton. But Liverpool Cathedral, the heaviest bell is 4 tons. As you can see from this little picture here, the sound that you make is about a second or less or more after you've pulled the rope. Split-second timing is essential for it to sound any good. There are no crib sheets, so when bell ringers are ringing, it's all in the head, all from memory. Lastly, it can actually be dangerous, and if you trawl the medical literature, you will find reports of bell ringing disasters where people have not caught the rope, got the rope caught around their neck and strangled themselves. There are actually a few fatalities being reported. Anyway, that was a brief introduction to change ringing. It's a tradition dating back over 300 years. This is the church where I ring, usually on the Wirral. I think it's an essential part of our festive soundscape. It's been practiced in England and Wales and some Commonwealth countries, and it's actually underpinned by group theory. And I'm now going to finish with the only bit of chemistry. This is Eternium Surprise Major for you. And as my chemistry colleagues will know, Eternium is actually one of my very favourite elements. So don't take the bell ringers for granted, please, next time you hear the bells ringing.